at is anytime you have a binomial, I'll put it in this form. It could be like ax plus b to times y to any power up here. We'll just put a z. We'll know how to expand this, what the coefficients would be, by following a pattern. The first guy who really came up with an idea was Pascal. He came up with a triangle, but we have a theorem to help us out today. So we're looking at binomials to any power. I know I put a z there. It kind of looks like a 2, but really it's just saying any power here. No matter what the power is, we can come up with how this would expand if you were to FOIL this out infinitely many times. So let's first start with Pascal's triangle. This will help us out. So here's what it's saying. When it says row 0, here is what it means. It means like, and I'll just do a plus b this time to keep it shorter. It doesn't matter what the binomial is. 2 things to the power of 0. If you multiplied everything out, if it had a power 0, you're left with just 1 as your coefficients. Because anything to the 0 power is 1. If you had a plus b to the first power, well, that would be simply a plus b left over. Now look at your coefficients. You see how this says 1 and 1? That means over here we have a coefficient of 1 and 1. Now I'll do one more here. If we had a plus b and we squared it, now we would need to FOIL this out, and we would end up with a squared plus, you'd have a times b, and then another b times a, which would give us 2ab plus b squared. If you FOILed it out, that's what you'd come up with. Notice here my coefficients are 1, 2, and 1, and this one up here was 1. See what's happening here with this Pascal's triangle? These values represent these values here, and so this would tell us that if we did another power, a plus b to the third power, and you multiplied all that out, you would end up having 1 with your a squared, or a cubed rather, and then what happens is you would have an ab term, a squared b term, and then we would have an a b squared term, and then we would have a b cubed term. That's how your powers work. The first one descends by 1, the b's increase by 1 all the way across, and then we could fit in our coefficients. It would be 1, 3 needs to be right there, and 1. So I put my plus. Let me put my plus there. I'll make it easier to see. And that's how it would multiply all the way through. So that's kind of Pascal's triangle. Notice 1s are always on the outside, and then all you're doing is you're adding the 2 values above. So here I have 3 because 1 plus 2 is 3. This is 4 because 1 plus 3 is 4. This one's 6 because 3 plus 3 is 6, and so on and so forth. Notice that 10 plus 10 is 20, or 15 and 20 is 35. So that's how you get all these values as we go across. So it says, use Pascal's triangle to expand this. And so I've copied over Pascal's triangle. We would go to the 6th row. This tells me our row. So we go to row 6, which is here. And so the expansion would be 1, a to the 6th plus, next comes a 6, so it would be 6, a to the 5th power, b to the 1st, plus, after the 6 comes a 15, 15, a to the 4th, b squared, plus, after the 15 is a 20, 20, a cubed, b cubed, plus, now we go to 15 again. This time it's a squared, b to the 4th. And after 15 we had a 6th, so 6, ab to the 5th. And finally, the last one would be 1, b to the 6th power. And this right here would be my value. Let me box this up. That would be our expansion. Now we'll do it again. We'll use this time 3x and a 2. Now here's where this gets a little bit trickier, is because what happens is we're no longer just a and b with powers. Now we have 3x and 2. So we would go to the 5th row, which is here. And so our values are going to be 1 times 3x, and it's going to be 3x to the 5th power, plus, then comes a 5. 5 times 3x to the 4th, times our b, which is 2, plus, next comes a 10, And so you treat this as A and this right here as B is what I'm doing. So then it's 10 times 3x cubed times 2 squared plus, after the 10 comes another 10, 3x times, 2 cubed plus 5, and I'm sorry, this is a squared, there you go, times 3x times 2 to the 4th plus 2 to the 5th power. And now we would need to simplify all this. We'd have to ask ourselves, what is 3 to the 5th? And I believe, let's see, 3 times 3 cubed is 27, so 3 to the 4th would be 81. 3 to the 5th is 243. So we would have 243x to the 5th power when I would simplify that. Plus here, this was 81 times 5, which is 81 times 5. Let me make sure I don't make a mistake here. I think it's going to be 405. So 81 times 5 is 405. And then we need to multiply it also by 2, which should give us 810, I'm sorry, 810. So I'm glad I did that. And so we have now 810 x to the 4th, and then here this is 27 times 10 is 270, and then you times it by 4, which is 1080 x cubed, I believe. Here we have 9 times 8, which is 72, times 10 is 720 x squared. Here we have 5 times 3, which is 15, times 16. 15 times 16 is 240, I believe. 15 times 16 is 240. And then 2 to the 5th is 32. And that would be our answer there. And so what I just did is I plugged in everything just like I did before, but instead of having just A and B, I set it as each one in parentheses, and then I would multiply out the coefficients using the proper powers. And let's see if this will give me a good box this time. There it does. All right, your turn to try with this one. See what you come up with.